video solution for test problem number 1. It says we have a solid sphere, radius r, carries total charge positive q. Party wants to know the electric field everywhere inside and outside of the sphere. So it also gives us a charge density rho of r equals ar cubed. The first thing it tells us to do is to find A. So if we know that the total charge is equal to the integral of rho r times d tau, the volume element of the sphere, this part, the sine theta, d theta, d phi, pulls out to give you a 4 pi. Plugging in rho of r, you get the A, and then r squared times r cubed from 0 to r, big R, dr gives you 2/3 pi a r to the 6th equals q. And then solving that for A, you end up with A equals 3q over 2 pi r to the 6th, big R to the 6th. So that's our A. And then finding the electric field outside of the sphere, we know that the integral of E dot dA equals q enclosed over epsilon naught. We already solved for q over here, so we can just simplify this to E dot A equals q enclosed over epsilon naught, where A is the area. So E times 4 pi r squared equals q enclosed over epsilon naught, where r is the radial distance that the electric field is outside of the sphere. Putting in q enclosed over here and bringing this 4 pi r squared over, we end up with 2/3 pi a r to the 6th over 4 pi r little r squared epsilon naught, and that's r hat. So E of r on the outside, after we plug in what A is, just gives us q over 4 pi epsilon naught little r squared r hat. And that is for little r is greater than big R. Alright, and then for inside the sphere, it's going to be the exact same with the exception of q enclosed is just going to be a little r, since it's still dependent on the radius at that point. So you end up with E of r equals 2/3 pi a r to the 6th over 4 pi r squared epsilon naught. After doing some cancellation, some simplifying, you end up with E of r, and plugging in A, E of r equals q r to the 4th over 4 pi epsilon naught big R to the 6th. And that's for r is less than big R. Alright, then part B, hold on. And the electric field at the radius of the sphere is just going to be the same. It should give you the same value for either one of these, which if we plug in little r here, that cancels out, and it does give you the same value for both of them. So that's what it's at the surface. And then the next part tells us to find the voltage, or the potential Yeah. It wants us to find the voltage at the origin, V of 0. So we know that V equals negative integral of E times, or dot, dl. Okay? And just using the one that we had for inside the sphere, the electric field for inside the sphere, we can make this integral of Q r to the fourth over big R to the sixth times dr. dl, the piece that we need in this case is r hat dr. So then the r hats cancel to give you 1, and you're just left with dr. This, you can pull out this q over 4 pi epsilon naught big R to the 6th integral of r to the 4th dr from little r to big R equals negative q over 4 pi epsilon naught r to the 6th times big R to the 5th over 5 minus little r to the 5th over 5, and then when little r equals 0, that's 0, and you're just left with, so that's 6, cancels with that, negative q over 4 pi epsilon naught r, and that 4 times the 5 is 20. So, there you go.